Today I will talk about distributed queries in Monet. But before you start watching this video, I suggest that you go to this web page here and that you read this article. This article about merge tables will help you to better understand distributed queries. Or you can go to YouTube and watch a video about merge tables with this title. I will now go back to this first web page, and I want to tell you that this example about distributed queries is long and fragile. That means that you should follow my instructions strictly, because later you may have a problem to create remote tables, so I want to follow everything step by step. I will start this example with visual presentation, so I will start with this image here. This image represents two servers, so today we will work with two MonetDB instances, and they will be on different computers. We have a green computer, green server, and on it we have these two tables, and we have a similar setup on the blue server. At the top we can see dimensional table, so we have dimensional table dim_G and dim_B. dim_G is on the green server and dim_B is on the blue server. These two tables, they have the same structure and they have the same data. So here we can see three products, and in this dim_B table we can also see the same three products. Besides the dimensional tables, we also have fact tables. So we have fact G and fact B. These two tables also have the same structure, but data in them is different. In fact G table we have sale data for 2025, and in fact B table we have sale data for 2026. I will now show you about remote tables. I will scroll down, and here we have a similar image as this image above, but now we also have remote tables. On the left side here we can see green server. This green server will again have two physical tables, dim_G and fact G, but beside that it will have remote tables dim_B and fact B. These remote tables are not real tables. They are just reference to tables that physically do exist on the blue server. So this physical table has a reference on green server, and that is remote table. So these are just pointers to real tables. They're not real tables. In the green server we now have two physical tables and two remote tables. But now green server has all of the data about our table. So he knows about all four our tables. So if we send a query to green server will be able to create an execution plan for that query. Also, that query will use data from the green server and also from the blue server. It is also possible to do the opposite, because on the blue server we have two blue physical tables, but we also have remote tables for tables that are physically on the green server. So this here is just a remote table for this physical table on the green server. So again, we can send the query to blue server, and blue server will be able to create an execution plan for that query. Also, that query will use all of the four tables. So what is the purpose of this? Well, purpose we'll see if we scroll down and if we look at this image here. Here on the left side, again, we have our physical tables on the green server and on the blue server. Now, when we send a query, for example, we can send a query to green server. Green server will create an execution plan, but that execution plan will do some calculation on the green server and some calculation on the blue server. So here we can see an intermediate result that will be calculated on the green server. So on the green server, we will join these two tables and we will group the result by product. So we will see sale in 2025 by products, and we will do the same on the blue server, but this time we will get sale by products in 2026. So we have two intermediate results. And then we will go to master computer. In our case, master computer is green computer because we have connected to green computer. So green computer will already have these intermediate results, but then it will also collect data from the intermediate results from the blue server. So both of those intermediate results will be collected on the green server, and then the final result will be calculated. And now we can see the purpose of distributed queries. The purpose is to divide our query between computers so that the execution is faster. I will now go here to terminal. We will start from scratch. So I will first create one folder with the name dbfarmg. Then I will initialize this folder as Monet folder by using MonetDaemon. So MonetDaemon create and then path to a folder. And after that, I will start my daemon. So our folder will be activated. I will start a daemon. And now we can create a database inside of our folder. And for that, we will use this console application MonetDB. So this is not a daemon. We will create a new database with the name database.g. It will be created in maintenance mode. So I will release this database so anyone can use it with MonetDB release. And now I will log into this database. The only user inside of this database is administrator. So I will log in as administrator. And my password is default password MonetDB. After that, I will create one role, one schema, and one user. I will first create a role. And I'm creating a role with the name role GB. GB means green blue. That is important because we have to create this role on both servers, on green server and on blue server. So I will create it. And this is important because when we send a query, that query will use tables from both servers. So we need to have the same account on both servers so that user can use all of the tables in his query. So that is why it is important to have everything with the same name on both servers. Beside the role, we will also create one schema with the name schema GB. And this schema GB will have authorization of role GB. That means that anyone who is member of this role will be able to use this schema. And we will create one user. This user will have schema GB as default schema and role GB as default role. So when he log into green server, he will immediately be able to use tables from schema GB. I will run this and then I will quit this session. I will also clean my screen. Now that we have created a new user, we can log in as that user. My password is GB with lower letters. And you should notice that the name of a user should use lower letters and the name of a database should use original case. I will now create new tables. So I will create table factg. I will insert data inside of this table. Then I will create a table dimg. And I will insert data into dimg table. After that, we can read from our tables. So I will use select statements to read from factg and from dimg, and these are our tables. Next, I will quit this session. Now I want to change one setting inside of Monet server. I will stop Monet folder, and after that I will read the settings of this Monet folder. I will use command MonetDB get all. And here we will see that setting. This is that important setting. Currently, only access to this server is from localhost. That is from the local computer. But I want to change that setting. So I will use this statement. I will set listen address to this IP address. This IP address means that any IP address can connect to our server. So I will run this, and we can then again read from our settings with get all, and we will see now that our setting was changed. After that, I will start my Monet folder again, and then we can run one Linux command to see who is listening to port 50,000. So we can see that port 50,000 is listed by MonetDB. I will now clear my screen. If you want to control who can connect to Monet server, then you should set firewall. I will first enable firewall by using sudo ufw enable. UFW means uncomplicated firewall, so I will enable it, and after that I will prevent any incoming calls. So no one from the network will be able to contact us. So I will deny incoming calls, and after that I will allow all of the outgoing calls. So that means that we will be able to call all other computers on the network, but I want to allow users to connect to Monet. So I have to relax this rule, and I will relax it by adding an exemption. So I will exempt access only for people with these IP addresses. So people from my local network, they will be able to connect to port 50,000, and they will be able to do that through TCP protocol. So this rule will work together with this rule. So only this will be allowed and everything else will be denied. I will run this. But the problem with this rule is that I have a local network with these IP addresses. You may have some other IP addresses in your network. So I will delete this rule because it is too restrictive for this example. So I will delete it. I will just say sudo ufw delete, and then I will repeat everything. And after that I will create one simpler rule. And this simpler rule means that I will allow anyone to connect to port 50,000 through protocol TCP. So I will not limit IP addresses that can connect to this computer. And after that we can check the status of our firewall. So we will use sudo ufw status, and this is the status, so anyone can connect through the port 50,000. If we create some mistake, or if we are not sure what we are doing, then we can reset all of the rules. So I will run sudo ufw reset. This will reset all of the rules. I will type yes. And now we have reset all of the rules, and we can also disable firewall if we want to. So we can use sudo ufw disable, and this is how we can disable firewall. I will now clean my screen. Now I'm currently using a virtual box, and these are virtual machines. So I have this green virtual machine and this is blue virtual machine. I have two virtual machines. If you are using VirtualBox, then you should change one setting. You should open settings for your operational system, and then you should go here to network, and you should change this setting to bridge adapter. This will allow this virtual machine to connect to local network, to be part of the local network, so our two virtual machines will be able to communicate. Now we have set up everything so that we can connect to green server from the network. So I will first go to the green server, and I will run this Linux command, and this Linux command will give me IP address of this computer. So I will run this, and this is IP address of the green server. I will clean my screen, and then I will connect to this green server. But for that I will jump to the blue server, and from the blue server I will connect to green server. For that I will use this command here. So again we will use mclient, but this time we will provide this IP address. So this is IP address of the green server. We will say that we are using port 50,000. We will connect as user GB, and we will connect to database G. So I will run this. My password is GB with lower letters, and after that we will try to read from dimg from the table that is on the green server. So if I run this, this will be successful. So although we are currently on the blue server, we can connect to green server and we can read tables from the green server. I will quit this session and I will clean my screen. I will now repeat all of the steps that we have saw from the start of a video, but I will do them for the blue server. I will first create a new folder, and then I will initialize this folder as MonetDB folder. Then I will start my daemon, And now I can create new database. The name of this database will be database B. And then I will make this database available. After that, I will log in to this database as administrator. My password is MonetDB. I will create my role, schema, and user. So I will create role GB. Then I will create schema GB that has authorization role GB. And I will create a user that will use schema GB and role GB. And after that, I will quit this session. Next, I will log in as this new user. My password is GB with lower letters. And then I will create two tables. I will create table fact B. I will insert some data into this table. Then I will create table dim B. And I will insert data into dim B. And after this, I will quit my session. And then I will stop my Monet folder. I will then read settings for this folder. So I will use command MonetDB get all. And we will see that we can currently connect only from the local computer. So I will change that. I will change this setting to IP address with zeros. After that, I will again start my daemon. And we can check whether we are listening to a port 50,000. And that is true. I will now clean my screen. And now I will connect to this blue server. But just like previously, I will connect from the opposite server. So I will go to green server. And from here, I will run this command. This is IP address of the blue server, so we can connect to it. We are using again port 50,000. User is user GB and database is now database B. I will run this. My password is GB with lower letters. And we can read from the dimg table. That is dim B in this case. And we are successful. So we can connect to one server from another server. I will quit this session and I will clean my screen. We will now see how to create remote tables on green server. I will log in as administrator because only administrator has right to create remote tables. My password is MonetDB. And the first thing is that I will set my schema to schema GB. And this is because my remote tables will reference tables in the blue server that are inside of the schema with the same name. So we have to be in the schema with the same name as the schema on that other server. After that, I will create my remote table dimb. For that, I will use this statement. So we will create remote table with this definition. And this table can be found on this IP address, on this database, and on this schema. So we have all of the three elements that we need. We will also use port 50,000. So I will run this, and this will be always successful. But we will only know that it is really successful if we try to read from this table. So I will use select from this dimb, and this is successful. This means that our remote table was successfully created. After that, we can do the same with factb table. So I will again create remote table with the name factb. This is definition of my table, and we can find my table here on this IP address. This is blue server. We will go through this port on this database, and of course we are using this schema GB. So I will create this remote table, and then we will try to read from this factb table. So although we are now on the green server, we can read from the table that is on the blue server, and this will be successful. Now we can create some replica and merge tables. I will first create one replica table, And this replica table has the same definition as dim-b or dim-g table. I will now try to read from this replica table, but this table is not a real table. It is empty. So we first have to add some tables to it. We will add tables dim-g and dim-b because those two tables are replicas. So I will alter this table dim, I will add table dim-g to it, and I will do the same with the table dim-b. And now these two tables, dim-g and dim-b, are tied to this dim table, and now Monet knows that these two tables are replicas. If we now try to read from this dim table, we will get the data that is inside of dim-g and it is also inside of dim-b. Now Monet can choose from which of these two tables it will read the data. It can choose any one of these two. And then we will create one merge table. And this merge table will have a name fact. And this is why I told you to read that article about merge tables. So replica tables are similar to merge tables. And now we will create the real merge table. We will again provide definition of our merge table that is the same as structure of fact G and fact B tables. So I will create this. If we now try to read from this merge table, we will again get the message that we should add some tables to it. So we will tie table fact G to this fact table, alter table fact, add table fact G, and then we will also tie table fact B. And now we will read from this fact table. These are merged tables. So in this case, we will get a union. So we will get all of the data from the fact G and all of the data from the fact B. So these are merged tables and these are replicas. They have the same data, but here we have different data. So we need to create a union. I will now quit this session and I will clear my screen. We will now execute all of the same steps, but on the Blue server. So I will jump here to Blue server and I will log in as administrator. My password is MonetDB. And the first thing is that I want to set my schema to schema GB. After that, I can create my remote tables. I will first create remote table dim-g, and then I will create remote table fact-g. After this, we can create replica and merge table. So I will first create replica table dim, and I will add two tables to it. First, I will add dim-g table to dim table, and I will add dim-b table to dim replica table. Then I will create merge table with the name fact, and I will add two fact tables to it. So I will add fact G table and I will add fact B table. We can now try to read from our replica and merge table. So I will first read from dim table. We can see here our products, and after that I will read from fact table, and here we will see data for both 2025 and 2026 year. I will now quit this session and I will clean my screen. We will now go to green server and we will take a look at some system tables. I will log in now as user GB. My password is GB with lower letters. And first we will read from the system table sys table types. And here we will notice that we have different table types. With 0, we have regular tables. With 5, we have remote tables. With 3, we have merge tables. And with 6, we have replica tables. And next, I will read from the system table sys.tables. And here I will search for all of our tables. So I will search for physical tables, remote tables, replica tables, and merge tables. So I will run this. And here we can see a difference between them. So we have two physical tables, factG and dimg. We have two remote tables, dimb and factb, and we have one replica table and one merge table. But where we can see what tables are connected to fact table and what tables are connected to dim table. Well, we can see that in this system view with the name sysdependencies view, and we will search for dependent type 2. So I will run this, and here we can see that we have this fact table, that is merge table, and that table has factG and factb, and dim table, which is the replica table, has tables dimg and dimb. I will now clear my screen. Now that we have prepared everything and that we have learned everything, we can finally see the result of our effort. As a user GB on this green server, I will run this query. And this query will use replica table dim and merge table fact. So it will use all of our 4 physical tables, and if I run this, this will be successful. And this is how we can divide load of our query on 2 servers on 2 computers. And this will increase the speed of our query. But we can also go to blue server, and on the blue server we can do the same thing. Here I will log in as user GB. My password is GB with lower letters, and I will run here the same query, and again I will use the power of 2 Monet servers. I will get the same result. Now, although now the load of query is divided between 2 servers, the server that we connect to will create execution plan. And if all of the users connect to the same server, that server will be more busy than that other server. In order to solve this, we have 2 strategies. I will jump here to this web page, and we can use natural division between users. For example, all of the users that are born between January and June can use green server, and all other users that are born between July and December can use blue server. But if we want to have a more professional approach, then we can use a special program. And that program belongs to class of programs that are called load balancers. One of them is HA proxy. I will now open this link here so we can see the web page where we can download this program. So users will not connect directly to servers. Instead of that, they will connect to this program, and this program will direct users to a server that is currently not busy. And that's how we can better utilize our servers.